Welcome back to our data cleansing playlist. In the last video, we learned how to load the data from different formats. Now let's explore our data to understand what we are working with. Let's get started. Before you clean your data, you need to understand it. Data exploration will help you to understand the structure and size of your data. It will also identify data types and potential issues. It helps you to find missing values, duplicates, and spot the outliers and anomalies. It will also help you to plan your cleansing strategies. Think of it as like a doctor examination before the treatment. Let's learn the essential tools now. Let us create a new notebook. Let us call it as 04 Initial Data Exploration. Let us start implementing data exploration. Let us start importing all the required libraries. Import numpy as np, import pandas as pd. We need these two libraries a lot. Let us create a new messy data here. np.random.seed. I'll set it as 42, and I want to create, let's say, 100 records. Let's start creating this data set. Create a messy data for exploration. So we can say df, which is going to be equals to pd.dataframe, and let us start adding some data. Let's say I want to create a column called as id with the range from 1 to n plus 1. So it will start with 1 and it will go to 100. Next, let's put the name as let's say something like, the structure could be something like this: person underscore I. This is going to be the variable that I'm going to use for I in the range of 1 plus n plus 1. So that's the name. Let's add a new column, age. Let's use the choice np.random.choice, and I want to choose the values like 25, 30, 35, 28, 32. Also want to add none, -5 and 150. Minus is a wrong value, we know that, but we want to go for finding out those issues later. So let's use that data here, and I want to repeat it n number of times. Let's add the salary. Let's follow the similar pattern, np.random.choice. Let's say 50,000, 60,000, 55,000. Like last time, I'll also add a none. Next, add, let's say, -1,000, which is negative. This is invalid, but we want to add it. And let's add 5 million, which is going to be an outlier. Let's add the city. Let's use the similar choice again. Sorry, we have to repeat it n number of times first. np.random.choice. Let's say New York. Let's say again one more, New York. This time I'll add all of them in small. We'll have to fix those issues later. Next, add New York. You can see all of them are something, all of them are having the same value but in different cases. Chicago. Also adding none and empty value. Repeat it n number of times. Let's also add department, which again going to be np.random.choice. So it's going to be like engineering. Let's go for sales. Again sales. Let's go for marketing. Notice it, I'm using different casing intentionally, and let's implement it. Sorry, let's repeat it n number of times. So this is my data frame. So if I look at this, I can see there are 100 rows, and you see the values are quite chosen from the ranges that I've provided here. Now we'll start understanding this data or visualizing this data. Let us start first by looking at viewing the data. Let's create a new section and say this is viewing the data. Viewing the data. So let us start with the first one. Say I want to get a list of first few records. So maybe I can say load the first 5 records, or let's say view the first 5 records. It could be done easily by saying df.head, and you see that first 5 records are shown here. Now sometimes instead of 5 I want to go for, let's say, 10 as well. So maybe I can say view first 10 records. Could be done easily by saying df.head 10, and I can see 10 records have been shown. Now similar to the head, if I want to read the data from the bottom side, I can use, let's say, view last 5 records. Could be done by saying df of tell. Head is for reading the data from top, while tell is the reading the data from bottom. Now like that head, I'm going to use another value here saying view last 10 records. Could be done by saying df.tell, and if I say 10, so I can see last 10 records here. Now sometimes I do not want to go for the top or maybe the bottom, but a randomly selected 5, let's say, n number of records. So maybe I can say view a random 10 records, 5, 10, you decide how many records you want to show. So maybe I can say df.sample, and I can say 10 for now. So I can see 10 values or 10 records have been selected randomly. If I execute it one more time, I see I'm getting some different records. So every single time this function is getting executed, it is going to give you the new records. Fine. So this is how we can view the records. Now that you understand how to view the records, let's continue further and understand the structure. Understanding structure, like how it is made up, how many rows, how many columns, so on and so forth. So let us start with the simplest one. First, get the shape of data set. Now this could be done by saying df.shape. Now when you say df.shape shows you a tuple with length of each dimensions. So there are 2 dimensions, rows and columns. So there are 100 rows and there are 6 columns, which is what we already have seen last time. If I want to really find out the columns here, I can say get the list of columns. Could be done easily by saying df.columns, and this will show me the ID, name, age, salary, city and department column. This is an index. If you really want to go for getting a list of them, or in the list format, I can say to list, and this will give me the actual columns in the list format. Simple as that. Now likewise, if I want to find out how many what are the different types of columns that I'm having here, I can also say df.dtypes, and df.dtypes will show me the column names along with their data types. Rather, I can say get the list of columns along with their data types. So this is very simple one that I can see here. It's going to be like ID, integer 64, name, object, so on and so forth. So only one is numeric, all of them are textual columns, right? This is the way we can get the list of columns along with the data types. You can also convert this into a dictionary if you really want to use it somewhere else. So I can say to dict. So this will give me a dictionary format. It's like the ID is dtype 64, name is like dtype 0, O for object, so on and so forth, right? So this is the way also we can get the information here. Now if I want to get whole information in one single call, get all generic information in one single call, I can use a method called as a info. So info will tell me how many rows you are having, how many columns you are having with the column names along with their data types, and how many non-null values each column is having. So this way I can understand the structure better, and this way I can also see the number of columns, their data types, non-null values, and so on and so forth. It also shows me the memory usage as well. If I really want to get that memory usage separately, I can say get the memory usage memory usage of the data frame. This could be done by saying memory usage, and this tells me per column how many bytes have been used here. If I really want to get the deeper understanding of it, so maybe I can say deep is going to be equals to true. So this will also show me some data, along with the data, how much memory it is using. So this is the way we can find out the memory usage per column. Entire df, it's already been shown here. This is like the per column deep understanding of it, deep memory understanding of it. Okay, so now you have understood like what exactly the way we can get the general information of it. Now sometimes we also want to get the statistical information as well. So this can be done by saying get statistical information. This can be done by saying df.describe. Now notice it, df.describe shows only the numeric column, because there is only one id column which is numeric and rest of them are objects. You can see it is not showing me all the objects, it's just showing me only id column. Now if I want to get the statistical information including the non-numeric values or non-numeric columns, this can be done by saying include all. So when I say include all, you see that it is giving me the information now for all my other columns. Those are object columns, and that's the reason you can't calculate the mean, standard deviation, minimum value, first quartile, second quartile, third quartile, so on and so forth. So it just shows me how many records you are having there, precisely non-null values, how many of the unique values that we see here, and so on and so forth. So you can get the information about both the numeric column and non-numeric columns here. So this is the way you can get the information for entire data frame. But let's say I don't want to go for all the columns. I just want to go for only, let's say, one column, say for example id. So maybe I can say get statistical information of selected columns. You could say column or columns, depends on your requirement. Let's say for example I want to go for an id and say describe. So this will show me the information only about the id column. Similarly, if I want to get the information of, let's say, two columns, say for example name and department. So this is the way we can get both the columns and try to get the information of both of them. So this was giving me whole information. This is going to give me information about a single column, and we can also do the job for multiple columns as well, right? So this is the way we can get the job done. Okay, so this is the basic understanding of the structure of your data set. Now sometimes you want to go for frequency count. Like I'll show you example, frequency counts. Okay, so frequency count means you want to find out how many values are repeated in your column based on frequency count. Means it will tell you how many times the value is appearing in the column. This can be done by using, let's say, get the frequency count of, say for example, city. So this way it will tell me, if I say df of a city dot value counts, this will tell me how many times New York is repeated, Chicago is repeated, New York is repeated, space is repeated, means so on and so forth. So this tells me how many times those values are appearing in your column, and that is going to be very useful when we are going for classification in machine learning. That way we can find out whether your data set is balanced or imbalanced. So this is a primary tool to check the data balance. It is value counts. Now say for example I want to get the topmost city, the one that is repeated multiple times. So I can just go for head and it shows me the top city which is repeated inside it is New York. So I can get this one here. Sometimes, right now if you see here, you can see entire data set, but if I just want to go for, say for example, not only for city, I want to go for city and say department. So you can say get the frequency count of city and the department together, department. So you can do the same job here, city and department. So you can see the city and department combining, like for example New York and cell is repeated 8 times, this New York and engineering is repeated 6 times, space and cells is repeated 6 times, and so on and so forth. So you can go for not one but multiple columns and find out the value counts of it. As I said, this is going to be very important when you are going in the classification to find out whether your data set is something like whether your data set is balanced or not. So that is why the value count is frequently used here. Okay, now let's continue further and let's look at couple of advanced techniques. In which case I want to find out how many unique values are available in your data set. Find the unique values. So this could be done by saying df.unique, and this will tell me df.nunique. So you can see that in ID there are 100 unique values because we have generated that values from 1 to 100. Same goes for name. In age there are 7 unique values. In salary there are 5 unique values, and so on and so forth. So basically you can find out how many unique values are there per column. So that is a very simple way you can check it. Likewise, we can also check how many missing values are there in your data set. So get the missing values could be done by saying df.isNA. Now df.isNA will show you the entire data set with 2 values, either false or true. Wherever you say true, at that time or at that place the value is missing. This is very difficult, so maybe I can say .sum, and this will tell me in ID there is 0 values missing, in name 0 values missing, in age 13, salary 20, so on and so forth. So these values are missing here. If I want to find out the total missing count, get the total missing count, we can add one more sum after it, and this will tell me total. If I just add all of them together, total 58 values are missing. If I really want to find out the total missing values, instead of saying count, percentage, then this could be done by using df.size star 100. So you see that total 9.6% values are missing, right? If you just want to go back here and say print total or percentage of missing values equals to, let's go back here and restrict it to 2f%. So now I can see this clearly. Total 9.67% values are missing. So this also tells me, like in this particular case, these values are missing. So almost 10% values are missing. In the next video we'll talk about how do we tackle those issues, but right now you can at least explore and find out how many values are missing here. Now sometimes you want to find out the columns with the required data types. Like for example, get the list of number columns, numeric columns you can call them as. So we can say df of selected dtypes, which includes we can say np dot number. So I want to go for a number column, right, like that, dot columns, and this will tell me how many columns which are having the type number. Don't worry about that because that's a type of index. If you really want to get it as a list, I think toList is better. So you can see this is the column, only column which is having of type number. If I want to do that for object, you can do it easily by saying something like np doesn't have it, you can directly say object. If you do it, you can see that rest of the columns like name, age, salary, city, the department, so on and so forth, all of them are object columns. That is it for data exploration. You now know how to understand your data. In the next video, we will tackle the missing values, one of the most common data quality issues. If you found this video helpful, please like and subscribe and help me to create more contents like this. See you in the next video. Thank you very much, guys.